Hello and welcome. Today we are going to be discussing symbols in geometry. And there's quite a few here. This is not every single symbol, of course, but this does cover quite a few. So let's go ahead and just take a quick look at a few symbols. Alright, our first one is therefore. Therefore is 3 dots. Looks kind of like a triangle that's not connected. It's got the 3 vertices, and it just means therefore. It's really there to be the last statement in a proof. So we'll get there when we get to proofs. It'll make sense. I would like you to take notes down, write these different symbols down, and probably even want to study them so that you can remember a few of the different symbols. Alright. Equal, we all know that means the same number, the same value. Equivalent. Equivalent is a little bit different than equal. The way I think of it is if I owned a cow and you owned a cow, the cows are equivalent in the fact that they are both cows. But your cow is not the same cow as mine. My cow is a different cow. If I were to sneak over to your house and trade cows with you in the middle of the night and think that's so funny, you now have my cow and I have yours, you don't have the same cow as before, although you might not know the difference because they're equivalent. But they're not equal because they're not the same animal. So equivalent means that they have the same qualities, but maybe aren't exactly the same thing. Maybe 2 triangles are equivalent in their size, but they're not the same triangle because they're not in the same place. One's in one position and the other's in another. Congruent. Congruent is similar in the sense that it's got a lot to do with equal. So congruence is the same length or the same area or same volume. So congruent usually is talking about length in geometry. So when we say congruent, we're usually talking about same length. So 2 line segments could be congruent in that they're the same length. Similar. This is just a single squiggle line, and similar just means that they have the same shape, but not necessarily the same size. So 2 triangles could be, in fact, the same shape, but not the same size. They would be considered similar, but not congruent. So congruent would be that they are both the same size and shape, whereas similar, they are the same shape, different size. So a real quick example. I've got here a Hot Wheels car, and it's the same shape as a real car, but it's not the same size. It's much smaller. Okay? So it's scaled down. So these would be similar shapes, this car to the real car, but not the same size, because you can't get in this one, but you could get into the real car. So that's the analogy there for similar. Okay. The next is segment. Segment, just a segment is a piece of a line, and usually we'd write segment, say AB. So segment AB, the segment symbol is the line over AB, and then the line symbol again would be written over line AB, and that's the symbol for line. And then the next is ray AB, and ray, we usually make it so that the arrow is pointing to the right. It's rare that you see it pointing to the left, but you can do it. Okay, if we have a capital letter, that is in geometry identifying that we're talking about a point. So point A. T here is lowercase. Whenever we're seeing a lowercase letter, we are talking about a line. Line T. So we can name it line T. Of course, we could name it line AB if we had 2 points, point A and B. We could name it line AB, but we could name the line itself line T. And that would be fine. And T is just an example of a letter. You use any letter you want. Okay? And I've got a cursive P, cursive letters, or we sometimes call them script letters, I believe. These cursive letters usually identify a plane. So like this whiteboard itself is a plane, and we could call it plane P. Plane P. So hopefully that makes sense. It's plane P. All right, we've got a few more, so we'll go through these. We've got the symbol for angle, and it is interesting. Some textbooks will say that with the arc inside of the angle, we're talking about the measure of that angle, and without it, we're just talking about the angle, but we're not discussing its measure. So how many degrees it is. So like a 90-degree angle, we would use the arc. But I don't usually think of it that way. I usually think of these two as being the same, just talking about an angle. Okay. When we want to talk about a measure of an angle, I usually put the letter M in front. So measure of angle. So the measure of angle. Okay. So those were angles. The next is two, it looks like L's, just right next to each other. 2 L's in a row, and it just means parallel. So these lines are parallel. It's a symbol for parallel. If two lines are perpendicular, meaning that they form a 90-degree angle, this here would be a 90-degree angle. That would be identifying perpendicular. So it's an upside down capital T. If you want to think of it that way, that is the symbol for perpendicular. Okay. Triangle. We use that symbol for triangle. There's other uses for that, because that's a Greek letter delta, and so it is used in other things in math, but generally speaking, in geometry, we use the triangle symbol to represent a triangle. Upside down A, it's not really something we're going to focus on a lot, but it's noteworthy. Upside down capital A just means all. It's just a shorthand for all. This is I believe epsilon. Hopefully I'm thinking of that correctly. Epsilon, and it's a Greek letter, and it just means to add up, or sum, the sum of parts. So we're going to have some kind of equation usually after this funny looking E, and it just means that we're going to add them up. So again, we already talked about this, but M and then an angle symbol just means the measure of the angle. So it means that we're doing some math to it, probably some algebraic work is happening here with the M. We could be adding or subtracting, multiplying, dividing, all that good stuff. So degree symbol. So an example is 90 degrees. This little circle in superscript, meaning that it's up above the 90. It's raised. It looks like a power of 0, but it actually means degree. So 90 degrees. Here I've got T, T prime and T double prime. So prime and double prime. And this is usually indicating some kind of movement of a line. So if we were to reflect across a specific line, so let's say I had line T and I wanted to reflect it across the x-axis, I could then have a new line, line T prime, and then I could reflect that line across the y-axis, and then I would have T double prime. So it's just identifying different movements and the steps to get there. So maybe this is our and answer. This is what we started with. So we've got the pre-image, and then we've got the image. So the pre-image is what you start with, and the image is what you end with. So pre-image and image. Okay. And then the last one I've got up here is arc, and that's an arc symbol. It's just saying that we're going part way around a circle. So if we had a circle and we had 3 points on that circle, and we had A here, B here, and C here. To get from A to B to C, we'd have arc ABC, or we could just say arc AC. That would be fine. You don't have to have the B there in this case. Okay. So there's a few more idiosyncrasies with arcs, and we'll get there. I just wanted us to get a kind of a picture of a few different symbols. So if you haven't written them down, I would say please go back and rewatch if you need to, and write down each of these symbols. They are going to be used in class, and I just want you to know what they mean, and they don't come as a surprise to you. There are other symbols that we will use in class that I didn't get up here, mostly because I just probably didn't think of them, and of course I ran out of space, so that kind of caused me to not get through all of them. But let's go real quick review. We've got therefore, equal, equivalent, it's a triple line. Congruent, it's an equal sign with the squiggle above it. Just the squiggle is similar. Just a little line segment, that's segment with arrows on it. It's a line with only one arrow on it. It's a ray. Point is capitalized letter. A line is lowercase letter. And a plane is cursive letters or script letters. We've got angles here. Parallel to line, two L's right next to each other, two lowercase L's right next to each other just means parallel. An upside down capital T means perpendicular. The triangle is a symbol for triangle. Upside down capital A is all. We've got the E, the funny looking Greek letter E, epsilon I believe is sum or add. Measure of angle, so the little m just means that we're finding its measurement. And you could use m of a segment as well, so you could have the measure of a segment. So this m can be used for measuring anything. Degree symbol, prime, double prime, there's of course triple prime, quadruple prime, and so on, depending on how many steps you have to go. And then we've got the arc. So hopefully that helps with some symbols that you're going to be seeing commonly in geometry. All right, thank you so much.